Welcome to the third part, part C, of a little mini-series on determining the initial weight estimation and initial center of gravity of the UWS-4 Ultralight Airplane. This is an aero design video from the Ultralight Airplane Workshop. So in part A and B of this series, I decided to use some weight estimation equations for the wing, horizontal tail, and vertical tail from Dan Raymer's book, Simplified Aircraft Design for Homebuilders. Now in part A, I just looked at the equations as they are out of Dan's book. In part B, I worked on some modifications to try to make them a little more applicable for ultralight airplanes. In particular, that's because we have a minimum gauge problem, which kind of modifies the surface area component of those equations. Now, if you don't know what I'm talking about, especially with minimum gauge, I'll put a link here up in the upper right-hand corner that'll take you to at least part B. And then, of course, that one has a link that goes to part A. So take a look at that to see what I'm talking about and to see what the initial weight estimation was. Here in part C, we're going to try to do the initial center of gravity estimation. And we're going to take advantage of a program called OpenVSP to do that. So let's get started. Well, I've brought up OpenVSP here, an application for configuring an airplane design. And I showed in the last video that you can use OpenVSP to try to calculate weight of components of the airplane, the whole airplane if you want to, and you can calculate CG, the center of gravity. Now let me show you a little bit that I've done here to help only bring up the stuff that I want to have the CG calculated on. Now what you see here is the airplane without the pilot. So right now what I want to do is calculate the entire weight of the airplane here, the empty weight. So what I've done is I've used sets. Sets is a capability that OpenVSP has. So for each component that I have in the airplane, if I want to, I can assign it to a set. So for example, let's bring up the wing. Now I have 3 different wings for this airplane. Right now you're only seeing one of them. And so that's another thing that sets are useful for. So I could put each wing in a separate set and do calculations on it separately if I want to. So right now we got the stubby wing on here. This is going to be the rectangular wing without winglets on it. So let's pick that. So let me bring up the parameters for this. We go to the general form, and if you come down here, there's a set export analysis. And anything that has a check mark next to it, this wing, which I've got selected here, is in that set. So example, it's in the set of shown because it's check marked. It's also in the set of wing because I got several different wings, so I put all those together in a set. I've got some temporary sets that I've been using here and there. One's called wetted total, one's called wetted clean. We'll ignore those for now. I also have these 2 others. One's CG FAA. That's when I want to calculate the CG with an FAA 170-pound pilot plus 30 pounds of fuel, which is 5 gallons roughly. And then I also have another set here called empty. So let me do something like this. Let's do a show only, because I show only the wing. Now what I come down here to do is this sets down in here. I can come in here and I can say I want to do an FAA set and do a show only on that. So now you can see everything, including the pilot, is now here. So that's a convenient way of bringing up something that I want to do a calculation on. Now generally, let me bring down the analysis for doing the mass properties. So here's the mass properties. Frequently, when I'm just playing around, I'm not sure what I want to do yet, I'll select a set here called shown. So anything that's showing on the screen will be included in the calculation. But another thing you can do is select a specific set. So I could come down here and select center of gravity FAA, and whether it's showing or not, it'll only do the calculations on that particular set. Something that I did last night is I went through every component that I want to include in my empty weight calculation. I made sure it was part of this set, the empty weight set, and then I also made sure that the weights on the component were correct, or at least pretty close to correct. So what we're going to do now is we're going to do a calculation and see what our empty weight is. So let me go back here. Let's do analysis. Prop. Let's select the empty weight. And let's see, let me crank up the number of slices here. Let's go up to 182 is good. Maybe just a little more, 190. And let's compute. Now it's a lot of slices, so it'll take a little while. So I may skip ahead here in a moment. Okay, it did the calculation. We don't see the pilot here, so the pilot's not included. And we have 212 pounds. Let me go back and compare that to the weight I got in the last video for the total empty weight. So in the total empty weight in last video, I have 223 pounds. So that's about 10 pounds less that OpenVSP is coming up with. And I think the main reason for that is OpenVSP will remove some overlapping areas. For example, I have these booms in here that come into the wing. You can see right here and here. So depending on how I set up priorities, it's either going to remove the portion of the boom that's inside the wing, or it'll remove the portion of the wing that's inside the boom. So that's going to remove some weight, which is okay. So 10 pounds isn't too bad. I think we're going to go ahead and at least proceed forward with working on our center of gravity. Now I'm going to keep an eye on things as I progress with the design, just in case I forgot something. I'll be able to come back and put the values in here correctly. So you can see right here, this little red dot, that is the center of gravity when the airplane is empty. In other words, when there's no pilot in it. So now what I want to do is do this all again, except I want to include the pilot. So if I come down here to my next set, this is going to be the center of gravity with FAA. So that's going to be a 170-pound pilot and 30 pounds of fuel. So let's do a show on that. We'll show only. Let's bring up our analysis window, mass properties, and I'm going to stick with 190 slices. And actually, I'm going to go ahead and change the set to the CG for FAA and compute. Okay, we got our slices. By the way, you can see how the slices are a little bit coarse, even though we have almost 200 slices. This is the carburetor and the engine and the redrive. So it's not going to give you perfect numbers on weight and on CG analysis, but it'll get you in the ballpark. For example, it has a very slim slice here on the propeller. But that's okay. We're just getting close. And now in the future, especially when I start working on detailed design, I can actually start working on detailed weights. In fact, if I really wanted to, I could go back to this, and for each of these weights in here, I could have OpenVSP do a calculation on the center of gravity for each one of these individually, and I could probably do something like 75 slices and get a pretty accurate CG then, and get a pretty good weight. And then I could do some moment arm analysis and come up with a pretty good center of gravity. But I'm going to go ahead and just use OpenVSP for this very first one to get me in the ballpark. So let me get rid of this mesh geometry and do a show on what we're looking at, and there is our center of gravity. Now I want that center of gravity to be at the 25% chord, or pretty close to that, of the wing here, at least on this initial design. So let me look in here. Looks like I'm at probably about 35% of the chord, around there, 37. I'm just eyeballing this, but right here is 50% chord. Right here is 25% chord. So it looks like we're a little bit behind it. So what I want to do, I'm going to go ahead and aim for getting it right up here about this line. And the way I'm going to do that is I'm going to move my pilot, my seat belt, and my seat forward. And I'm going to end up having to move my rudders and probably my nose gear and part of the fuselage forward too, which is going to add a little bit of weight. So it's going to take a little bit fiddling around. Now what I could do, if I were back using the spreadsheet like I talked about, I could probably reverse engineer it and calculate it right on the money instead of having to fiddle. But I like using OpenVSP, it's a lot of fun. So I'm going to fiddle with this, and I'm going to get that center of gravity up a little closer, and then we'll be right back. I've moved the pilot a little bit, and that's moved the CG a little bit forward, but I wanted to show you a little something I did that OpenVSP lets you do that's pretty handy. But I've also assigned the seat and various parts of the seat belt to the pilot. So when I move the pilot, that moves with the pilot. So that's pretty convenient, so I don't have to move them each individually. Now I've got the pedals and the nose wheel, that's actually attached to the fuselage. So I'll have to move the fuselage for that stuff to move. So just to show you what I'm talking about, I've got the pilot selected. I've gone here to X form, and I will move the X location forward just a little bit. Now it was 3.99 feet, so I've moved it, 0.3 something feet forward. So it's about 4 inches forward, 3 inches forward. So I'm going to move forward just a little bit more. Let's go down to about, yeah, let's try that. That's not a whole lot, maybe, man, just a little bit more. Okay, try that. So I'll come back here and I'll do a compute again. So I'll leave this alone so that you can see how much the dot moved. So I went, about 0.2 feet forward with the pilot, the seat, and the seat harness. So let's see how much that moved. So right now the XCG is at 5.5 feet. So let's try this again. All right, we just did our mesh. In fact, you can really see the mesh slices here, like the front wheel, main wheel, the pilot here. So you can see those slices pretty evidently. So you can see it's somewhat coarse, but it'll be good enough for what we're doing here. So let's go ahead and delete that and take a look and do a show all, or actually show only. So it did not move very far. Yep, it didn't move very far at all. So you can see what I talked about fiddling around the way I'm doing it now. So I'm going to go continue fiddling around with this off camera, and then when I get, I'll talk about one more thing that I will do once I think I've got the CG pretty close. I'll move everything else in the airplane backward. I want to keep my datum line, which is just a little bit in front of this nose here, where it is. So once I get the pilot roughly where I think it's going to be, instead of moving the nose forward, I'll actually just move everything else in the airplane backward. So that's how I'm going to deal with that issue. So I'll be right back. You know, I decided to show this to you anyway, because I think maybe it'll be some benefit to you guys. So what I want to do is I want to move this cockpit forward and the stuff that's attached to it. Now, some stuff I probably would prefer for it to not move, because what's going to move is like this rollover protection and this little engine mount part in here, this rectangular part. And let's see, but the rudder pedals will move, which is good because I want those to move. And the control stick will move. That's good. I want that to move. One thing that will not move is the main landing gear. I'll have to do that separately. So let's at least show you what I'm going to do here. So I'm going to move this front of the cockpit forward, in fact, the whole cockpit, until the rudder pedals touch the bottom of the feet here. So let's go ahead and do that. So what I'm doing is I've got the cockpit chosen here, the open cockpit, which is just a beam. I'm going to come down here to X location, and I'm going to slide that forward until the rudder pedals are right there under the feet. That's good. Now you notice this moved, and this little triangular piece in here moved forward too. And the control stick moved too. So I got that all where I want it. Now I could possibly leave this nose wheel where it is, but I don't think it will. I think I'll go ahead and move it forward. But anyway, I need now to move this back of the cockpit back where I want it to be. So this very pointy part right back in here, I want it to come back to this aft spar back here. So let me go ahead and work on that. So I'm going to come up over here to cross section, and I'm going to come to this spot here, and I'm going to move this back. I'm going to do it with this delta X. So let's move that back. I'm going to move it back until we're back where this pointy spot comes in contact where the rear spar is going to be. So I like that. I'm going to move the triangular piece back to where the front edge of it is close to where the fore spar is going to be, and the back part of that should be back here where the engine mounts touch. So I need to switch over to the engine mount extension is what I'm calling that. So you can see that's selected now. So I come back to X form. Now it's attached to the fuselage, so it's actually moving relative to the fuselage. So let's move X location back. More perfect. Okay, now let's come to the rollover protection. There's rollover post, so I'm going to move him back in the X direction. Now he actually goes just in front of the spar, so I'm going to stop there with him. Now I need to move my fuel tanks too. Now I don't have to move the fuel. The fuel is attached to the fuel tank, so all I need to do is move the fuel tank. So again, come up to X form. Now I'm just kind of guessing on that because I think the fuel tank is going to be somewhere right in here. Now this is not a structure, it's a point source. So I just put it in a blank, and I assigned, I think it was 3 pounds to that. Yeah, 3 pounds. So that's how I decided to work with that instead of putting actual structure in there. So now let's do the front nose wheel. I'm going to move it forward. So here's the nose wheel. So I'll only have to move the nose wheel itself, actually the parent group, because the tire, the hub, the axle, the leg, it's all attached. So once again, let's come up to X form, and now we're going to move that forward to about there. All right, I think we have everything we want. So let's do compute on the mouse properties again. All right, just finished the computation. Let's get rid of the crosscut. Let's bring back all of our parts. That's very, very close to being right. That's very close to the 25% chord. So for now, that's good enough. Now, as I said in the previous video, I'm almost certain when I start working on the forward and aft CG limits, I think this tail, the horizontal tail, is going to get smaller, which means we're going to lose weight back here aft, which means I'll end up having to move our pilot aft a little bit, because the CG would try to move aft if I only change the tail, making it a little bit smaller. And also, this pilot looks like it's a little bit too far forward to me, so I'm a little bit suspicious of that. I'm going to go ahead and continue on with the design. I think that'll be good. Now, I also have two other pilots. I have a 110-pound pilot, and I have a 250-pound pilot, 257-pound pilot. Now I'm going to start using those when I start working on the forward and aft CG limits, because that's kind of the pilot range I'd like to be able to haul. So what'll end up happening there is, let me bring up that pilot real quick. Okay, here's the male. The 157-pound pilot will cover 90% of males in the US. So that's what I decided to go with there. So let me show that real quick. We'll do a show. So you can see where I had that pilot originally. So you can see the pilot's bigger, the head's a little bit taller, bulkier. So what I would like to do for the aft CG, since this pilot's going to have to set back a little bit farther, I think I'll have a pilot with full fuel being my aft CG limit. And then for my lighter pilot, let me bring that one up. So there's my lighter pilot, obviously not in the right spot. For the lighter pilot, that will cover all but the bottom 10% lightest female pilots. Now that may be too optimistic for me. I may not be able to go to that light a pilot. I may have to add ballast somewhere in the nose if I have a really light pilot. But initially, I'm going to try to get a 110-pound pilot to fit without having to do anything extra. Okay, so obviously this female pilot's in the wrong spot. Let me go ahead and move her forward. So we can move her up to where she can touch the pedals. So that's where I would like to have that female pilot. Let me go back to the 90% male pilot and move it up to where its feet are touching the pedals. So that's what I'm going to work on initially. I'm hoping I don't have to move the pedals. So that would be where my 100 or 257-pound pilot would weigh. So what I want to do is I'll do forward and aft CG, but I'm not going to do that in this video, because if I remember correctly, Dan Raymer starts talking about in the next section on stability. So I'm going to leave that for the next video. So that's the end of what I'm going to do here in part C. It's the end of the initial empty weight for the airplane and calculating the CG. Now, I don't expect things to stay the way they are. Like I said, it looks like the pilots, to me, are sitting a little bit too far forward. But I think this is probably a good starting point. So what I'm going to end up doing as far as the weight goes and the CG locations is I'm going to start doing some more detailed structural design. Now, the wing isn't going to change based on any CG changes. It's dependent entirely on load. So no matter what I do with CG, the airplane wing's going to stay the same. And the booms and the tail are probably not going to change too much except for the size of the tail. Let me bring that back up. So the height of this tail is probably not going to change. I want that to be right above where the prop is, where that prop blast is. So it's not going to go any higher. Also, because of the 50-degree angle here that I want to be able to land at, so this bottom of the boom, it could come a little bit lower, but I have to limit the angle that I'm landing at to like 12 degrees if I need to have a little bit lower here. And this horizontal tail is not going to come any far forward, because the 30-degree angle coming off the trailing edge of this wing determines how far forward I'm going to be able to make that horizontal tail, because in a spin, I don't want the horizontal tail to be blanketed. From 30 degrees from this trailing edge to 60 degrees from the leading edge, that's all kind of blanketed. That's kind of a rule of thumb that you don't want to have your horizontal tail anywhere in that blanketed area from the wing if you're in a full stall, full spin. You still want to have that horizontal tail to be effective. So it's not going to come any far forward. So for the most part, the position, at least of this leading edge of the tail, is not going to change. Size of it may change. The width probably won't change, and that's because of where the booms are. I want this airplane to go into a 8-foot wide trailer. So from the outside of the boom and outside of the tail is 7.5 feet. So I can just barely get into an 8-foot trailer, at least most 8-foot trailers. So that's not going to change. Width probably won't change. I guess it could be narrower, but I don't think I'll do that. What I would like to do is retain my 72 inches of width here between the booms, just in case I can find a larger diameter prop. I don't think it's going to happen, but I want to leave myself that option. So if I change the size of the horizontal tail, it's going to be the chord that will change. So once we get through the static stability calculation and we get the final size for the horizontal tail, and I'll probably at that time also have a final size for the vertical tails, then I can start detailed design on the wings, the booms, and the tail. And I don't think any of those dimensions from that point forward will probably change. So that portion of the airplane, where those weights are, will be fixed. So they won't change the CG anymore. The way I'll be able to change the CG is probably just placing the pilot and maybe the forward landing gear. I could tweak that a little bit. So that's what I'll use to move the CG. Now that also means if I have to move the pilot, I may have to redesign the fuselage. So this forward portion of the fuselage, I'll come up with the general shape and general design of it, but the length of it, I'm going to have to leave open until I've figured out the weights of the wing, the booms, the tail. I'll also have to figure out weights for the engine mount. The engine also will be a part of figuring that out, the rollover. I'll probably be able to design that and not have to change it. That's part of the fuselage. Where it attaches to the wing, I should be able to come up with a fairly final design on that, so I'll be able to size that. So at the end, this front part of the fuselage will end up determining where that CG goes. And I want, at least for the 170-pound pilot, to have that close to 25%. I would prefer to have it close for the other size pilots, but my guess is that for the really light pilot, it's probably going to move aft. For the really heavy pilot, it's probably going to move forward. And that's where my aft and forward CG limits come into play. So I'm going to have to figure that out. Well, guys, I hope you found this interesting. We're still making progress on the design, so I'm happy where we're headed at the moment. Thanks for watching. Until next time. If you haven't left a video, hold on. I decided to go ahead and do the calculations for the light pilot and the heavy pilot. So if you made it to the end of the video, you get to find that out. So I just did the calculation for the 170-pound pilot, the FAA pilot. And so you can see the little red dot right here. Now I went ahead and did the calculation for where the CG is as a percentage of the wing chord. And so this is 26.1%. So it could move forward another percent in order to get to the 1/4 chord. But this is fine. Let's go ahead and stick right now with this 26.1%. Let's now go and look at what the light female pilot's going to be. About 110-pound pilot. Oh, by the way, keep in mind, this is with a full load of fuel, which is a little bit behind the CG. So when we get down to empty, that'll end up moving the CG forward a little bit. Okay, instead of making you go through all the process of doing it, I just went ahead and did it. So now you can see the dot is right here. Now what the 170-pound pilot is about there, that was 26% of the chord. Now back here, I did a calculation. This is at 31% of the chord. So it's moved back. It's not too bad. My guess is that my most aft CG will be about 33%, with 35% being the neutral point, something like that, maybe a little bit more. So I really would rather not go any farther aft than that. Now that means that I want my baggage probably to be right here just behind the seat, but in front of the rollover. Because if I put it back behind the rollover, that would be behind the CG. For this lightweight pilot, that would move the CG even farther aft, so that wouldn't be quite as good. All right, now let's do the heavy pilot, the 257-pound pilot, and see what happens there. Okay, we just did the heavy pilot, and that CG turns out to be at 20.4% of the chord. So that's pretty far forward, but it's not as bad as I thought it was going to be. Now, keep in mind, the fuel is behind the CG, back in this area, so once it burns off, that's 30, it's not going to be a complete 30 pounds of fuel. You'll have some fuel left in the tank, but that's going to move the CG forward a little bit. So we could get maybe down to probably 19.5% probably. that's getting pretty far forward. With the forward CG, if you want to be able to have your forward CG go even more forward, you just make your horizontal tail bigger. So this went forward a little more than I expected. But once we go through the static margin calculations, static stability calculations, we'll see what we come up with. It's possible that I'll have to make it so that the rudder pedals can move backward a little bit to move this heavy pilot back a little bit. And for the really light pilot, we may just have to add ballast to the nose of the wing in order to move that CG forward. And none of this is final. This is all just rough initial calculations. So for example, it let me get my pilots closer to where they probably will be at the end, because clearly I was off to start with. I had the pilots too far back, at least based on what we've come up here with OpenVSP. Well, that's enough for now. Thanks for watching till the end, guys. Hope you enjoyed this little extra content. Till next time.